Hi, I'm Mr. Kangas, and today we're going to be taking a look at Chapter 12, Section 2, Measures of Variation. And in this video, I'm going to be showing you how to find the range, the inner quartile range, and the outliers of a set of data. So up on the board, I have a random set of data that I just made up. Okay, so these numbers aren't anything special, but I have 1, 2, 3, 4, 5, 6, 7, 8 numbers up here on the board. To find the range, it's something that most of us are pretty familiar with, and you take the smallest number, which in this case is 10, and you subtract it from the largest number, okay, which in this case is 40. Remember, when you're doing anything that deals with range, inner quartile range, outliers, mean, median, mode, etc., your numbers need to be in numerical order. You can see my numbers go from least to greatest. Okay? So, smallest number subtracted from the largest number, that is range. Okay? So the range in this case would be 40 minus 10, which is 30. So 30 would be your range. So that's a pretty simple concept. I think most of us have had that one ingrained in us since elementary school. Now, the part where you may run into some issues is when we start discussing the interquartile range. So, if you take a look at the word interquartile, inter usually refers to the inner or the inside of something, and quartile means it's something that's split into 4 pieces. Okay, so basically, the interquartile range is the it's the 2 quartiles that are inside your data when your data is split into 4 pieces. So you take this rectangle and pretend it's my data, and we split it into 4 pieces like this. Okay? These 2 pieces here would represent my interquartile range. Remember, these are 4 equal pieces. They have to be the same size. Okay, so if you split your data up into 4 equal pieces, then you will have 4 quartiles, and the interquartile range will be the distance from will be the distance between the 2 inner quartiles. So these are the 2 inner quartiles. These would be the 2 outer quartiles. So the distance from right here to right here would be your inner quartile range. Okay. So basically, you're going to take this number and subtract. You're going to subtract this number and this number. So if this was 20 and this was 10. Your interquartile range would be 20 minus 10. So in other words, your interquartile range would just be 10. Okay, because 20 minus 10 is 10. So that being said, how do you split your data up into quartiles? How do you split it up into 4 equal pieces? Well, the first thing you got to do is find the median, because the median is going to cut your data right down the middle. It's going to cut it in half. So do what you do to find the median. I typically cover up the first number, the last number, and then the first number. Last number, first number, last number, first number, last number, first number. So our median is actually right smack dab in the middle there. So this is our median. Okay. Now, if you want to find, so now we have it split up into 2 equal pieces. We got 4 pieces of data on each side. Now I need to split my data up into quartiles. So what I'm going to do is I'm going to find the medium of the lower half, and I'm going to find the medium of the upper half, and that should split my data into 4 equal pieces. I had 4 numbers, so I went cover up the first, cover up the last, cover up the first, cover up the last. Line goes right in the middle. Okay. First, last, first, last. Okay. So now I have my data split up into 4 quartiles, 4 equal pieces. This is considered the lower quartile. This is your upper quartile. I now have my 4 quartiles. These 2 inner quartiles are where my inner quartile range is going to come from. I'm actually going to take my lower quartile and I'm going to subtract it from the upper one. So this line is between a 12 and a 15, which would make this a 13.5. You have to find the number that lies between the 12 and the 15 to figure out what the lower quartile is. In this case, it's 13.5. The upper quartile lies between 38 and 39, so this is going to be 38.5. So your inner quartile range, in this case, okay, also known as your IR, your inner quartile, you can call it your IQR, inner quartile range is equal to 38.5 minus 13.5. Which is going to equal 25. So your inner quartile range is 25. So far we've talked about finding range and your inner quartile range. Make sure you are taking good notes. Make sure you are following the proper format for taking your notes. Please make sure you pause this video if you need time to take notes. And if you have any questions, pause this video now and ask me. Don't wait until the video is done, because if you're confused now, you won't understand what's to come. Alright? So, we've taken our data, we found the median, the lower, and upper quartiles. We split our data into 4 equal pieces or 4 equal quartiles, and we found the inner quartile range by subtracting the lower quartile from the upper quartile. The last thing we want to talk about today are outliers. Okay? Outliers in a set of data are usually extreme values. These are pieces of data that we typically don't include when we're finding averages and accumulating statistics, because these are pieces of data that are so far off the rest of the data. They're so far out there that they can actually change the averages and the statistics and percentages significantly, and they can make you think that something occurs more often than it should. Or, for example, this set of data ranges from 10 to 40. Now, let's say for a moment that we had these numbers for our set of data, and then I had one number which was at 230. So I have one piece of data that's way out there at 230, but this is the rest of my data. When I go to find the average, if I include that 230 in this set of data, it's going to make my average look a lot higher than it should. So that it's kind of like, that piece of data really doesn't belong. That was just more of an exception to the rule. It was a blip on the radar. It's a once in a while occurrence, but here, this represents the core group of data, so this is what you want to work with. Outliers are not something you want to include in your data, because they're going to make your data misrepresent something. It's going to be misleading, and it won't be something that you can look at and really get any information out of. So how do you find outliers? How do you know if your number is an outlier? Well, here are all of my numbers in my data. I have a 10, 12, 15, 15, a 32, 38, 39, and a 40. So I have 8 pieces of data. What you do to find the outliers is you take the interquartile range, which in this case is 25, and you multiply it by 1.5. So we're going to take the interquartile range times 1.5. Okay? So in this case, interquartile range times 1.5 would get me 37.5. Right? I'm then going to take that number, I'm going to take the interquartile range times 1.5, and I'm going to add it to the upper quartile. And I'm going to take the interquartile range times 1.5, and I'm going to subtract it from the lower quartile. I'm going to take the lower quartile minus the inner quartile range times 1.5. Okay? If any of my data is, so here's my upper quartile, I'm going to add 37.5 to that. If any of my data was bigger than that, so that would take me up to 68, 69, 76. So if any of my data was bigger than 76, it would not count. It would be an outlier. None of my data goes above 76. My highest piece of data is at 40, so I am fine. I would then take a look at the lower quartile. I would take the lower quartile and I would subtract the 37.5 from it. Take away the 13.5, so we do 12.5, and we're down to 25. This one was 24. So negative 24. So if I took 13.5 and I subtracted the 37.5, I would get negative 24. Okay, that's going to be like way down that way. If any of my data was below negative 24, it would be considered an outlier. Okay? None of my data is below negative 24, so with my current data set, I have no outliers. Okay? So one more time, I'm going to explain that one more time, just in case you got a little overwhelmed there. You're going to take the inner quartile range, you're going to multiply it by 1.5, and you're going to add that to the upper quartile range, and that's going to get you an answer. If anything is above that number, it's an outlier. You're then going to take that same inner quartile range, multiply it by 1.5, and now you're going to subtract it from the lower quartile. If anything is below that number, it is also an outlier. There are two types of outliers. You can have outliers on the lower end, you can have outliers on the upper end. So you need to test to see if you have outliers on both ends, like I just explained. Okay? Other than that, there's one more thing I want to go over, which is what happens if instead of having an even number of data, I have an odd number of data. Okay? So what happens if I have 10, 12, 13, 17, and 21? Okay, odd number of data. Okay, first thing you want to do, find the range. Doesn't change anything. Okay, you're still doing 21 minus 10, you have a range of 11. But if you want to find the inner quartile range, you got to find the median. First, last, line goes right down through the 13. Okay? Now, if I want to find the inner quartile range, I'm going to go first, last, line's going to go between 10 and 12. First, last, line's going to go between 17 and 21. Okay, I now have 4 equal quartiles. I have a quartile with one number, one number, one number, and one number. So that's the key thing. Once you find your median with an odd set of data, the line goes right through the median. So the median in this case is 13. When I go to split the lower half, when I go to find the median of the lower half, I don't use the 13. 12 is the number I'm going to use as my last number, and 10 is my first number. So you don't count the 13. And same thing goes with the upper half. I'm not going to count the 13. I'm going to start with the 17 and I'm going to, as my first number, and the 21 is my last number. So at this point, we would have 11 for a lower quartile, and between 17 and 21 is 19. And so then my inner quartile range, or my IQR, would be 7. And once again, if you want to take the time to do it, you multiply this by 1.5, add it to the upper quartile, subtract it from the lower, see if you have any outliers. You'll find, once again, I do not have any outliers. But that is all there is to Chapter 12, Section 2.